Hello and welcome to this look at a quite tricky calorimetry and Hess's law combined 6-mark question. We'll start off by having a look at how to read and process the question so that you can plan a sequence of steps in your answer. In other words, where to start and where to go from there. This is the first part of the question where it gives you some key information about three reactions that are interconnected to each other. And the way that they're related is via the Hess's law diagram that you can see. Now, it says a student carries out an investigation to find the enthalpy change for the decomposition of magnesium chloride. And this one is reaction number 1, which we've highlighted both at the top and also where it sits in the Hess's law cycle. So the idea would be that you're going to work your way around from here to here. And in doing so, you'll come up with an expression whereas delta H1, which is the unknown we're trying to work out, is delta H2 moving in the same direction as the enthalpy arrow for reaction 2 minus delta H3 moving in the opposite direction as the enthalpy arrow for delta H3. Excuse me. So the next part of the question gives us some information about what the student actually did. So like we said, delta H1 is what we're being asked. At the bottom you can see the student calculates delta H3 for reaction 3 is minus 136.1 kilojoules per mole. So we can stick that into our Hess's law cycle and come back to it a little bit later. Delta H2 we don't know at this particular point, but we have all the information on this table and in the student's method to work it out. So the idea is that once we have delta H2 we can put a number in for that and then we're away. We can insert delta H2 and delta H3 into our expression and work out delta H1. So let's have a go at working out delta H2. So zooming in a little bit on the information we're given, it says add about 100 centimeters cubed. And you've got to be careful here because about 100 centimeters cubed is not the same as actually how much it was added. So don't fall into the trap that many people do of assuming it's 100 grams for M and Q equals MC delta T. What we've got to do is look carefully at the data you're given, and you can see that there's a difference between those two values, which will give you actually 103.01 grams. So that's what they mean by about 100 centimeters cubed. It ends up with 103.01 centimeters cubed. You're making the assumption that the density of the solution is the same as that of water, and you're also making the assumption that the specific heat capacity of the solution, which would be C, is the same as that for water, which is 4.18, which comes from the data sheet you'd get when you're doing this in an actual exam or paper. So we can start thinking about what goes into Q equals MC delta T. We need to also work out delta T itself, and that's fairly straightforward, because all you have to do is work out the difference in the starting and the finished temperatures, which happens to be 5 degrees Celsius at this point. So put those numbers in, and that gives you 2152.909 coming out of your calculator. But that's in joules, so that needs to be converted into kilojoules. You can either do it now, or you can do it a little bit later. I would advocate maybe doing it sooner rather than later, otherwise you might forget. So then it says hydrochloric acid is added, and it's an excess. And it also says add 4.215 grams of magnesium carbonate. Now looking at the reaction they're referring to, you can see that magnesium carbonate and HCl are both reactants. But if you look closely, you can see that because it's an acid reacting with a base, making a salt plus water plus carbon dioxide, it's a neutralization. So what we really want is the number of moles of water that's made. So here's where there could be a slight trap. If you were to go for working out the number of moles of HCl, you'd be applying a 2-to-1 mole ratio. If you're going for using the number of moles of MgCO3, you'd be going for a 1-to-1 mole ratio. So which one is it? The clue lies in the fact that hydrochloric acid is in excess. So therefore the limiting reagent, and therefore the reagent that controls how much controls how much water is made, is the 4.215 grams of magnesium carbonate. So, like we said, the number of moles of magnesium carbonate to water is 1-to-1. If we work out the number of moles of magnesium carbonate, we will get the number of moles of water. So then delta H2 is minus Q in kilojoules over the number of moles of water. So minus Q, like we said earlier, was 2.152909 kilojoules. Now I said minus Q. That's because it's a temperature rise, not a temperature drop. So you stick the minus in because energy is being lost. So this is going to end up with a negative number for your delta H value because it's obviously an exothermic reaction. Another one to be careful of is the minus won't actually fall out of your calculator, so you've got to insert that somewhere to remind yourself. So just to recap on the use of a 1-to-1 mole ratio, you can see that magnesium carbonate and water are in the same molar quantities. So therefore that's why we assumed that magnesium carbonate to water is 1-to-1. So now we've done all our thinking and our calculating, we need to just present it in the way that the examiners want us to. So the first thing to do is to put down our Q equals mc delta T, then the number of moles of water that we're using, and then the delta H2 calculation, and then finally stick that into our Hess's law application calculation. That gives us plus 93.04 kilojoules per mole. So the key marking points are in bold and black, and the final mark, you can see there's 5 marking points there. The final one would be for general layout and organization of your answer, remembering it's the 6-marker marking style. Okay, hopefully this has been a useful look at what's quite a tricky question. As always, thanks for listening. Until next time, see you again.